Welcome to today's episode of the California GACCs Weather Terms video series. Our topic for today will be atmospheric stability. In this video, we will cover the differences between a stable and unstable atmosphere, as well as the impacts both can bring to wildland fires and prescribed burns.
Atmospheric stability is a reference to how air behaves when it is lifted under certain weather conditions. A stable atmosphere is one in which air tends to sink, and an unstable atmosphere is one in which air tends to continue rising on its own. The main factor that determines stability is how much temperature changes with height in the environment compared to the typical rate that air cools as it rises. Both the stable and unstable atmosphere have implications on fire behavior and smoke dispersion, which we will go over a little later. Recall in the first video of the California GACCs Weather Terms series, we discussed troughs and ridges, which are fundamental aspects of atmospheric circulations that define weather patterns. In that video, we mentioned that in areas that are dominated by a ridge, the atmosphere is more stable. Under high pressure, air descends to the surface and warms as it compresses, leading to weather conditions that are typically calm and usually sunny. Oftentimes there is a strong temperature inversion under high pressure areas, especially during the calmer and cooler overnight and morning hours. An inversion means that the environmental temperature increases as you move higher in altitude. This phenomenon creates a warm lid that strongly suppresses vertical motion, leading to air being trapped near the surface. In the troughs and ridges video, we also mentioned that in areas that are dominated by a trough, the atmosphere is more unstable. Under low pressure, air at the surface converges from all directions and is forced to ascend. The air cools as it rises, leading to condensation of water vapor into clouds and potentially formation of precipitation. As a result, an unstable atmosphere commonly leads to unsettled weather. Now let's talk a little about the impacts a stable and unstable atmosphere can bring to wildland fires and prescribed burns. I mentioned earlier that under stable conditions, the weather is typically sunny. However, low-level stratus clouds and fog can form when moisture is present alongside cooling air. In California, this is most common along the coastline with the marine layer and in the Central Valley with tule fog. The strong inversion prevents these clouds from vertical development, so they have to spread out in the horizontal. A strong inversion combined with strong sinking air can sometimes lead to significant reductions in visibility with very dense fog. In a similar vein, smoke becomes trapped near the surface and is forced to spread out in the horizontal. This poor dispersion then strongly reduces air quality due to the trapped pollutants. Trapped smoke can also lead to reduced visibility. For prescribed fire activity, this type of environment is not ideal, especially near a high population center. On the flip side, a stable atmosphere reduces fire growth potential and fire behavior settles down. This is the most ideal environment to improve control and containment on existing wildland fires, especially when winds are light. The opposite is the case for an unstable atmosphere. Smoke dispersion becomes very good as the strong lifting will lift pollutants away from the surface and improve air quality. This is a much more ideal environment for prescribed fire, though there is a fine line before there is too much instability that would give way to an enhanced fire behavior. Strong amounts of instability and lift can lead to plume-dominated and erratic fire behavior that can be difficult or impossible to control.
That's it for today's episode of California GACCs Weather Terms. We hope you now have a greater understanding of atmospheric stability and how stable and unstable conditions can impact wildland fires and prescribed burns. Thanks for watching, and we'll see you in the next one.